Let us see about Z transform. After completion, the students can able to understand the relationship between the Z transform and Fourier transform for discrete time signal, and they can also understand the characteristics and properties of Z transform. They can compute transform and inverse transforms, and they can also apply transforms for analyzing linear time invariant system. Is a transform of a sequence x of n is given by the formula x of z equal to summation n equal to minus infinity to infinity x of n into z power minus n. The z transform can also be thought for of an operator. It can be used by the operator z of x of n equal to summation n equal to minus infinity infinity x of n into z power minus n equal to x of z. And the Fourier transform does not converge for all sequences, and the infinite sum may not always be finite. Similarly, the Z transform does not converge for all sequences and not for all values of Z. And the set of values of Z for which the Z transform converges is called the region of convergence. As x or converges is if x of z equal to summation n equal to minus infinity to infinity x of n into r power minus n, which is less than infinity, and this leads to the condition summation n equal to minus infinity to infinity x of n into z power minus n, which is less than infinity. And for the existence of Z transform, the ROC therefore consists of a ring of Z plumb. And here this is some other way in which we are marking the ROC. Here this is the inner circle which denote the unit circle, and the outer circle which denote the poles. Circle may include the origin, and the outer radius may extend to infinity. And also, if the ROC includes the unit circle modulus of z equal to 1, then the Fourier transform will converge. And we can see some of the properties of the region of convergence. The properties of the region of convergence depends on the nature of the signal, assuming that the signal has a finite amplitude and that the Z transform is a rational number, and the ROC is a ring of disk in the Z frame and centered on the origin, that is 0 less than or equal to a real part of R less than modulus of Z less than real part of R less than or equal to infinity. And the Fourier transform of x of n converges absolutely if and only if the ROC of the Z transform includes the unit circle, and the ROC cannot contain any poles. If x of n is finite duration, that is 0 except for then the ROC is the entire Z10 except Z equal to 0 and Z equal to infinity. If x of n is a right-sided sequence and the ROC extends outward from the outmost finite pole to infinity, and also if x of n is left-sided, then the ROC extends inward from the innermost non-zero pole to z equal to 0. A two-sided sequence has a ROC and consisting of a ring in the z plane and bounded on the exterior and interior by a pole, and the ROC is a connected. And we can see some of the properties of Z transform. First one is linearity. Linearity properties state that if x of n, the Z transform of x of n is x of z and y of n is y of z, then a into x of n plus b into y of n equal to a into x of z plus b into y of z. And next one is the time shifting. There is if x of n is the transform of x of s, then x of n minus n naught equal to z power minus n naught into x of s. Here, while we are proving y of z equal to summation n equal to minus infinity x of n minus n naught into z power minus n. Here we have made a substitution that n minus n naught equal to m. After substituting and after rearranging the terms and taking the constant term, we are getting the equation like that. There is z power minus n naught into x of z. Here the z transform, we want to prove that n into x of n, the z transform for this is minus z into dx of z by dz. Here let x of z equal to summation n equal to minus infinity x of n into z power minus n, and here we are having minus z dx of z by dz, which is equal to minus z into, here we are differentiating that particular term with respect to z and taking the constant term outside, and again we are grouping the term. We are getting that the z transform of n into x of n equal to minus z into dx of z by dz. Conjugation, that is x conjugate of n, it is the z transform for x conjugate of z conjugate. Convolution property, if x of n is the transform of x of z and y of n is the transform of y of z, then The property says that x of n convolution y of n equal to x of z into y of z. Correlation property. If x of n is a transform of x of z and y of n is a transform of y of z, then the convolution property states that x of n convolution y of n equal to x of z into y of z. And last one is initial value and final value theorem. The initial value and final value theorem of the Z transform are different. Initial value theorem for a causal signal x of n. The initial value theorem states that x of 0 equal to limit z tends to infinity into x of z. This is used to find the initial value of the signal without taking inverse as a transform. And final value for theorem for a causal signal x of n. The final value theorem states that x of infinity equal to limit z tends to infinity z minus 1 x of into x of z. This is used to find the initial final value for a signal without taking inverse as a transform. These are some of the possible questions in quiz questions is the transform.